This video will show you how to calculate the pH of a weak base. The steps are very similar as if you were to calculate the pH of a weak acid. Just a few subtle differences. You're going to be working with a base, so you'll need a Kb expression, which means you're going to need a Kb value. From there, we're going to find the hydroxide concentration and then solve the equation. However, there's a couple of ways you can go from once you've got your hydroxide concentration. You're welcome to then go straight through and find your hydroniums and pH, but some students like to convert that to pOH and then pH, and both ways will give you the exact same answer. But I'm going to find my hydroniums and then pH, so that's the method that I'll take in this video. We make the same two assumptions when we're calculating the pH of a weak base, and that is that the concentration of those hydroxide ions will be the same as the conjugate acid, which means that we can replace the conjugate acid with a hydroxide. It's making the assumption that no hydroxide ions come from the actual water itself. We're also going to make the same assumption about the starting concentration of the base being the concentration of the base at equilibrium. So it's basically assuming no dissociation, but trust me, you'll get the same answer. So let's get straight into an example where they've given us the concentration of an ammonia solution, and notice that they've given us the pKa of the ammonium ion. This is very common, and it is a trick to see that you know that you're dealing with a base here, and so you don't want a pKa or even a Ka. You are going to need a Kb value, so we'll have some extra little multiplication steps there which we must show in our working. So step 1, give yourself the dissociation equation, and this reminds you that the proton is being accepted onto the ammonia, so it is a base, and it's producing those hydroxide ions. Next step is to write yourself out your Kb expression, so that is the concentration of your products over your reactants. From here, I'm going to take the pKa value and get my Kb. So step 1 is to convert it to a Ka using 10 to the power of negative pKa. So this is the inverse log of your pKa. Process that in your calculator and check that you get a value of 5.75 times 10 to the minus 10. Once you've got your Ka value, you now need to find your Kb, and we can do that using the water dissociation constant over Ka. So 1 times 10 to the minus 14 over our Ka value, and that will give us our Kb. As I said, the assumptions are the same, so we're going to be able to replace the ammonium ion with a hydroxide ion, and you'll find the equation now starts to look like this. Kb is the hydroxide ion concentration squared divided by the ammonia. Now it's time to rearrange the equation, and we'll find the square root of Kb times the concentration of your weak base. Once you've got that rearranged, you can start substituting your values in. So now we replace the Kb with the Kb value, and we use the concentration of the ammonia and find the hydroxide concentration. From there, I'm going to find my hydroniums. Now, yes, you can go and find pOH at that stage and then find pH. That's fine, you'll get the same answer. There's more than one way to solve this in these final stages. But I like to find my hydroniums at this point, which I use 1 times 10 to the minus 14 over the hydroxide concentration. So that gives me a value for my hydroniums at 1.07 times 10 to the minus 11. Final steps is to now substitute this value into the pH calculation, so negative log of that value, and we get a pH of 11. Take a moment to check that your answer has got 3 significant figures and is a reasonable answer for a weak base, which 11 is a reasonable answer. It is basic to begin with, so it's higher than 7, and it's not too extreme, so that would be a good week-based calculation, or value rather. Now is a good time for you to practice these calculations, so I'll get you to complete page 277 in your SciPad, and I'll see you in the next video.